You know, refrigerant will lose sensible heat on the discharge line. Throughout the first and second lines of the condenser, you have what we call deep superheating. You know, deep superheating, which is the reverse of superheating. The superheated gas losing a bit of heat. But it continues to change in state, so you have a mixture of liquid vapor in the condenser, especially at the middle of, of the condenser, you get that. Towards the end of the condenser, the refrigerant condenses completely. So you get around here. It's not totally at the end, but it's nearing the end. You have the refrigerant saturated, so you have a saturated liquid, and that is the point where you have the bubble point. So the temperature you record on the high side gauge, which is the condensing temperature, refers to the state of the refrigerant at this point towards the end. Yeah. After that, it begins to subcool. It begins to subcool before it comes out of the condenser. So that subcooling is what we are measuring. Yeah, is what we are measuring around here, and the difference here. So towards the bottom pipes of the condenser and the temperature at the outlet of the condenser. That is why if you look at the handout I've given you, if you look at the handout I've given you, you can see the first example. The first example says roughly refrigerant enters into the condenser at the temperature of say 70 degrees C. 70 degrees C, it will desuperheat at the top, and then it continues to change in state, and then by the time it gets to a point close to the bottom pipe, you have the temperature coming down to 39. So the condensation of 39 continues throughout the surface of the condenser towards the end. So that 39, you take a temperature at the outlet of the condenser. So it's somewhat close to the bottom pipes, but again, at the end of at the outlet of the condenser, take a temperature from there. So for instance, we are getting a condensing temperature of 39. Now that condensing temperature of 39 is what we are recording on the high side gauge. There, and that is what you have. Towards the bottom of the condenser, or towards the last pipes of the condenser. And then you stick your thermometer on the outlet pipe. Get a temperature from there using your probe. And that, in this example, we have 34 on the pipe outlet, and then we have 39 towards the end of the condenser. So you do the subtraction, 39 minus 34, and then we get what? 5. So 5 degrees of superheat is normal. That is all. That is normal. So that is.
So anything above it is a problem.
If it's above it, say you have 10, 12 subcooling, that means the condenser is overcondensing, and it means you have too much liquid in the condenser. It could be that you have, say, you overcharge the system slightly, not to the level where it will affect the compressor, because overcharge can create high head pressure. Pressure will increase in the condenser, but then you are at a stage where that overcharge is causing overcondensation. Overcondensation. Too much liquid is going into the evaporator or in the condenser. Okay, any more?
So overcharge, what do you want to do if you do?
If you overcharge the system, you have to recover part of the refrigerant. People used to let the gas out, and they just slack that a bit, open the valve, and then the gas goes out. But that has to stop because of the climate change and all that. So now the laws are being enforced, and we have to follow the law. So you need to recover. Get your cylinder, get your scale, and then recover the amount that you need based on what you've detected, and then you carry on. Any more questions?
Is this the most accurate way to determine whether you've got the right size condenser or not?
It is the most accurate way. It is the most accurate way of knowing that the condenser you've got is the right, is matching the evaporator and the compressor.
So
it's the most accurate.
So that means that you could come to a machine and it could be wrong. The condenser could be the wrong size.
Exactly, it could be.
But then how would it have started working? Would it over time start to fail and come faulty, or would it, as soon as you put it both together, would it just break down?
I mean, as soon as you put the wrong condenser there and install it, you start the system. If you take all the pressures and the temperatures and all that, you will see that there's something wrong. But when you have engineers who don't know what they are doing, they leave it like that. So it will cut down the efficiency of the system. System might work for the customer for maybe 1 week, 2 weeks, 3 weeks, and then it breaks down. And then you have to go and check it. So anytime you go on the unit, if you do the subcooling and your superheat, yeah, with your subcooling you can confirm that the condenser has a problem, and then you can rectify it.
So
yeah?
How do you know what condenser you're going to need to work with your compressors? Because obviously you know you're an engineer.
Yeah.
And as you said, you could buy the wrong one.
Yeah.
And fit it with it's only going to last for 2 weeks. So how do you definitely know it's going to be the right one for it to run sufficiently?
Yeah. Every condenser has a capacity. So you have condenser capacity. So when you do your heat load calculation and you get your compressor or your total heat load, you use that to select your condensing unit. If you select your condensing unit, that will come with the condenser, compressor, condenser, and the fan. But if you should buy them separately, yeah, then there is a matching. You go on the technical data. You look. We use the data. You calculate. You got the capacity of the compressor. You match it on the data with the condenser. You know, so you get it right. Sort of. Every manufacturer has got a technical data
so you see
to match them.
And on the actual data, how am I going to know? Is it in numbers that would it be exactly the same serial numbers, or would it be like the same capacity, so 10 watts, 30 watts? You know?
Exactly, it will be in kilowatts. Say if you have compressor of, let's say, 10 kilowatts, yeah, they might probably give you a condenser of, say, 8 kilowatts. Yeah, so it's all on the data. If you can match it straight away. Otherwise, you can calculate the condenser capacity as well. We calculate condenser capacity, yeah, and when you calculate condenser capacity, it will be related to the load. That's the heat load you use to calculate the compressor. So that will, you end up getting the right capacity, you know, to match the same. Because you are using the same factors. The factors you use to calculate the heat load, you use some of those factors to calculate the condenser capacity.
So both of them must be some factory or can be different.
They have to match.
Some factory.
Yeah, you have to match. They have to match. Condenser and compressor must match. Yeah. Yeah. Okay. So, any more questions?
Yeah, I have a question. If you get the correct superheating, does that mean the condenser, the subcooling, is going to be okay? So if one of them's okay, then the other one's okay.
Yeah,
you know what I mean?
it normally follows. If one of them is okay,
yeah,
it follows that the other one is also okay.
So if one of them's off, the other one's off.
Yeah, but you still have to confirm.
Still have to confirm.
Yes, you have to confirm, because when you install a unit and you are getting the right superheat and all that, you know it's working. It's giving you got the right amount of gas. You're taking the temperature in the evaporator. You are getting the right temperatures. You check your back pressures, and the back pressures are correct, your temperatures are okay, you haven't done subcooling, but you know straight away that it's good. But then you still have to confirm it, you know.
Yeah.
Because the moment this one becomes, let's say the condenser is over condensing, it will affect the capacity of the evaporator, and that will affect your superheat.
Yeah.
Your superheat will go down very low.
Yeah.
Yeah. Okay. Any more? Good. Now make sure you understand this exercise or this task, so that when you are practicing, you can go straight into it. It's very simple. It's just like the superheat we did. Very simple. Run the system, take the temperature from here, take the temperature from the outlet, subtract the condensing temperature from the outlet temperature, and that's it. You get your subcooling. You just have to know where you are. Now, if say you check your subcooling and your subcooling is too low, like we said, 2, 3, and all that, there is undercharge. What should you do? Charge the system up. Just like we did for the superheat. Charge the system up. Yeah, because your condensation is low. It's not condensing properly. That is one. But before you charge the system up, check the fins. Are your fins straight? Yeah, no bends and all that blocking the airflow out. Is there anything blocking the airflow? You know, check that as well. and check whether the condenser is dirty. It's got foulings, papers, rubbish sticking, on it and blocking the airflow. You have to check all that. Then if you have to service it, you use your condenser cleaner. Yeah, spray condenser cleaner on the condenser fins and then soak it. Give yourself some time and then you can wash it. You can brush all the rubbish out. Clean the condenser and that can improve the condensation. Sometimes you don't have to charge at all. You just have to clean the condenser, service the condenser. When you give it a good servicing, it can improve the condensation. Maybe that's all you need. But if you do it and still condensation is low, say 2, 0, 2 or 1, then you have to charge the system up. Charge it up. Now, the other side is also true. If you do your condensation, your subcooling check, and you get high subcooling, say 12, that also means that there's too much liquid going through the condenser. Now, check your condenser condition. If it's okay, no problem, you may have to recover some of the refrigerant. You may have to recover some of the refrigerant to bring the condensation to sort of bring it down a little bit. It's too high, bring it down. Recover some of it. Too much going through, recover some of it so that the amount going through will then be cut down. And that will reflect in your subcooling.
How do we know how much to recover?
Yeah, how much to recover? If you check, it's very difficult to determine how much to recover. But what you do is, we recover in small quantities. You just take small, like 200 grams, and look at the reaction of the system. Wait for about 10 minutes, let it run, let it settle, check again. If you check and it's still high, then you recover maybe 500 grams, and then you check again. So you are monitoring the system to make sure, because you cannot really say, oh, because the subcooling is up to 12, then I need to take out 1 kilogram of gas. You can't determine that. You need to recover the gas.
But a good judgment would be about a minimum of 200.
Yeah, you start from 200, and then you add another 200, you go to 500, and you see that you are there.
Good. What chemical are we going to